After knowing some things about the laminate, let's talk about the assumptions of a laminate. Alright, so far we have been talking about all about laminate, but there are assumptions that we need to take in order for the definitions and things to go on quite smoothly. Okay, and therefore it's actually from your page 46 or lecture note part 2. Okay, but you can read yourself, but there are some things that I want to highlight. The first thing is that the laminate thickness is very small compared to its other dimensions. So this is a 3D body. Alright, the thickness is very small. This means that you're talking about a laminate that is something like a plate. And this is why we are using a plane stress assumption. Okay? This is also why we are talking about Qij bar. Okay, Q bar itself is already a reduced stiffness matrix. Okay, because it's talking about a 2D already. Alright, as you can see, it's a very small one. 3x3 system is a plane stress analysis. Alright, it's talking about a plate. Okay, if it doesn't look like a plate, then you're gonna have this type of matrix coming out, which is very big. Alright, that's why we have to actually simplify things in a way that is actually in terms of a plate. So this is why we are talking about plane stress assumption. Okay, hopefully this is pretty clear. This is lines perpendicular to the surface of the laminate remain straight and perpendicular to the surface after deformations. So to the surface, so I would believe this is actually the breadth of the thickness of the surface. I mean the thickness of the laminate. So this is the view if you were to go into 3Ds like that. So I do a 2D one. So over here, this is the line, the so-called the line, apostrophe the line, right? So it's perpendicular to the surface. So if you were to, so deformations means what? So if you were to pull this thing, or if you were to pull this thing, this line over here remains straight. Alright, although you have like so-called expand it, but this line over here remains straight. Alright, and this is what it's trying to say. Right, because normally if you were to pull, sometimes this thing over here may look like this. Okay, something like this lah. Yeah, or something like this. Yeah, if you were to pull in this direction, this thing over here may actually curve. Alright, so this is the assumption that they are trying to say. Okay, and I may be wrong, but at least you get a meaning of that lah. Then the laminate and the laminate are linear elastic. So the laminate, alright, talks about different plies stacked together. These are called laminae. Alright, and if it's a laminate, you're going to talk about a protective layer on top of it also. The full thing all together. Alright, a protective layer. That's all it's trying to say. And yeah lor, I may be wrong also, but this is what I searched for. Laminate has a certain cover, but laminate is just some different plies, that's all. It's a thin ply lah. Or maybe it's just a one ply, I don't know. But anyway, in any of the case, they are linear elastics, means that they are talking about Hooke's law. This is the strain, this is the stress. If you were to pull it up to the yield strength, it will break, or it will not deform. Okay, it will only up to here, and then it will break. This is the elastic region, Hooke's law. Okay, this is the assumption for the particular composite. Okay, and then over here, through the thickness stresses and strains are negligible. So through the thickness also again, if you were to draw in this direction, if I were to go into 2D now, alright, this is the 3D form. If I were to go 2D, alright, if you were to stretch this thing, alright, the in between this section will actually be stretched, alright, be stretched into this thing, right? So we are actually not keen to actually look at this strain. Alright, we assume that the whole overall strain. So we assume only the overall strain. So initially the original length may be like this. So if you were to pull it, it may becomes like this, right? So we're only looking at this portion. Alright, while instead we are not looking in the individual section. Alright, we are not looking in the individual section and then take a look on that. So these are the assumptions that hopefully it helps. But I may be wrong in this explanation, but something of the meaning. And the rest I think is quite straightforward already. And small deflections, I will believe is the crack. Okay, so you will have this thing, these are our fibers, and the diffractions are some crack over here. Alright, if it's a very small crack, it's okay. Alright, so these assumptions are good if it is a not damaged one, or if it is a pretty small crack, then you'll use all these assumptions. Okay, so it's a total of 5 assumptions, and I think this is a fair bit of stuff. See you there.